Well, hello chemistry students and welcome to high school chemistry. This is your very first video for the year and we're starting out talking about something that you may or may not have already studied. I think you've probably heard a lot of these concepts already, but we're talking about matter. So we're starting out with a pretty simple discussion of nature and states of matter. And I'll just ask you the question, what is matter? So while you think about that for just a little bit, we'll move to the next slide. Well, there are two characteristics that must happen in order for something to be matter. They must have mass and they must occupy space. So that's it. If something has mass and it occupies space, then it is matter. And here are just some little examples below. Obviously, water, it has mass, it occupies space, a tree does, sand does. And whether or not you think that oxygen is matter, oxygen does have mass and it occupies space. It does not matter how tiny the mass is or how small the space is. Anything that occupies space and has any amount of mass is matter. So oxygen is matter as well. Another important quality that matter has is that it has a particle nature. So this is kind of a fancy way of saying that, particulate nature of matter. If we look at this nice big space full of sand, that's a lot of matter there. If we take a little bit of that sand in our hand and we look at it under the microscope, we'll probably see some individual little sand particles there. Those still are not atoms. Atoms are so tiny that it takes an incredibly powerful magnification to be able to see them, and a microscope isn't nearly powerful enough. In fact, this is a picture right here, not of sand. I couldn't find one of little sand atoms, but or atoms in some sand. But this is a picture that is taken on something called a scanning tunneling microscope. It was invented in 1986, and it allows us to be able to see individual atoms. These here are little individual atoms of silicon on a surface. And right here is a single atom of antimony, and this is a little complicated. The antimony is actually reacting with some of the silicon atoms and affecting them. But this gives us a picture of what atoms look like on an individual scale. And I'm sure you've heard some of these analogies before, but just to give you another one, if we took, let's say, a hydrogen atom, and we blew it up to the size of a basketball. And we did that same thing, took that same ratio, and did it with a dime. So we take a hydrogen atom, blow it up to the size of a basketball. We take a dime and proportionately blow it up in the same way. It will be larger than our moon. So it just gives you a little bit of an idea of how tiny atoms are. However, all matter is composed of tiny little atoms. So here's a question for you. While we're talking about matter, what is different between this picture, and this picture? Kind of a silly question, but it's a really profound question. Each of these pictures shows a similar substance, or the same substance, water. However, it is in different states. And again, you may have already learned this before, but here we have the solid state of water. We call it ice. Here we have the liquid state of water, it's just called water. And here, if we think about the water particles in the air, that is the gas phase of the water. So what is different about these three states of matter? Well, a solid down here, when water is a solid, or anything for that matter is in a solid state, it has a fixed shape and a fixed volume. It does not move to occupy the container that it's in. It's a solid shape. It's also the most tightly packed together in that state of matter. If something then is in the state of a liquid, it will take the shape of its container. You can just think of that with water or any other liquid for that matter. It also still has a fixed volume. It is the volume that it is. It has the volume it has. It's a little more loosely packed so that the molecules can move across one another and it can flow, and that makes it a liquid. Now, when any matter becomes or enters its gas phase, that is a little bit different. It has no fixed shape and no fixed volume. If we were to take this little stopper here and press it down and make the container a smaller volume, well, that gas would accommodate to fill that particular volume. So it does not have a fixed volume, and it certainly doesn't have a fixed shape. If we were to open this stopper, in other words, the gas would just go wherever. It's not confined to a particular shape. So those are the three states of matter. And if you just stick with me, we'll talk a little bit about things you might like to do for advanced proficiency. So in order to achieve advanced proficiency, as we've been discussing in class, you just need to go above and beyond. So ask yourself, what can I do to go above and beyond? What can I research further? What can I do just that's incredibly special and way over what's just required? And here, I'm occasionally on these videos, I will give you some ideas, but please do not feel confined to simply the ideas I give you. Right here, I'm just saying research something related to matter, its nature, its states, whatever you find interesting, please go there, because that's the most interesting for you, and it'll probably be the most interesting to me too, to see what kinds of things you come up with and things that you research and that you do, because I'm sure you have great ideas. But one that you could look into is plasma. It's a fourth state of matter, and you may or may not have studied it before, but ask yourself some questions about it. What is it? What are its characteristics? Where does it occur? How does it occur? How common is it? And tell me all about it. You can do that any way you like, and I'm looking forward to hearing what you come up with. So thanks, and we'll see you in class.